As you all know, the elements in the nature, any object we see around, contains elements and their compounds. So, as you can see here, copper, silver, carbon, and zinc, several other elements are there. All these elements has one individual part. It is called atom. As we know from the periodic table, there are more than 100 different types of elements, and each element has a certain number of electrons in it, neutrons in it, protons in it. As you can see, hydrogen, helium, lithium, sodium, potassium, rubidium, so many elements are there. Let's look into the inside of the atom. Atom, the individual part of an element, contains electrons traveling around the nucleus. Nucleus is the small part inside. This is called nucleus. Nucleus is contains protons and neutrons. So electrons which are having negative charge revolve around this nucleus like planets around the sun. If you get inside the nucleus, you can see there are certain things to see about an atom. An atom is relative size is 10 power minus 8 centimeters. That is 1 angstrom unit. Whereas a nucleus is size around 1 Fermi, 10 power minus 15 meters or something like that. And proton is still smaller. Again, nucleus contains protons and neutrons, and each proton contains certain particles called quarks, which will we study later. If you compare the size of the nucleus compared to the atom, if you see the stadium here, football stadium, if you think that stadium diameter is an atom, the if a bee travels in it, the size of the bee is a nucleus. Such a small size occupied by the nucleus when compared to the atom. So you can imagine how much small the nucleus compared to the atom. Now let's see nuclear scale, the size of the nucleus when compared to other things. Now, if we see the common matter, the matter contains the crystals. The crystal size is around nanometers, that is 10 power minus 9 meters. Now, the size of the atom is in angstrom units or 10 power minus 10 meters. That is 1 by 10 power 10 of the meter. And the atomic nucleus, the inside of the atomic nucleus, you can see it is 10 power minus 14 meters. That is around Fermi. 1 Fermi equal 10 power minus 15 meters. Then we will get nucleons. Nucleons are the particles inside the nucleus that are protons, neutrons, like that. So the nucleons like protons and neutrons size is less than Fermi, 10 power minus 15 meters. So these are all bound by nuclear forces, which will be discussed later. And again, each proton and neutron will be made up of quarks, like up quark and down quark. So that is the nuclear scale. That means the human length is around 10 power my is around 1 meter. Common average man height is around more than 1 meter. If you take this nuclear size is 10 power minus 15 meters. So imagine how much small the size of the nucleus or atom compared to the things we will see around. The atom size is 10 power minus 10 meters. Nuclear size is 10 power minus 14 meters. Proton size is 10 power minus 15 meters or Fermi, and electron is 10 power 18 meters, less than 10 power minus. Such a small size. All these are called subatomic particles. The particles inside the atom are called subatomic particles. Now the notation, as you all know, the notation for the element is AXZ. A is the mass number, Z is the atomic number, X is the element. Suppose if we take the carbon here, carbon has a mass number of 12, atomic number of 6, and C is the symbol of it. So 12 is the mass number. So it contains 6 protons, 6 neutrons, and 6 electrons. So atomic number indicates number of protons and number of electrons, which are both equal as the atom is neutral. So remaining are the neutrons. So each isotope has the same number of electrons and protons but different number of neutrons. So this symbol is very much important for our nuclear physics. Like that, please note down this number. Now the subatomic particles. Atomic particles which are inside an atom and their sizes. If you see the electron, it has a negative charge of -1, and its relative mass, and compared to proton or neutron, is 1 by 1840. That much less weight than proton and neutron, and its actual mass is in grams 9.11 into 10 power minus 28 grams. Similarly for proton, which is represented P plus, charge plus 1 and relative mass 1, and actual mass is 1.67 into 10 to the power of minus 24. If you take the neutron, it is a neutral particle, it has no charge. So neutron is represented by N, and its charge is 0, and relative mass is 1, and actual mass is 1.67 into 10 to the power of minus 24. And proton and neutron masses are nearly same. Yeah, so that is about the subatomic particle.